All right, so some announcements that I have for you today. If you are interested in applying for the summer research program, I believe they're still accepting applications. It's something that happens over the summer where you get assigned or you apply and get assigned to a faculty mentor, and then you work on research projects in the summer. Research here meaning you may know like research papers where you like go and you discover all these sources and then just like compile them all together. Sometimes that's research. Sometimes it's like going and reading academic papers and then reporting back, here's what I noticed that connects all of them. Sometimes it involves actually doing experiments. So like there's chemistry, um, biochemistry, psychology type of projects that you can work on, and also computer science. So I'm one of the people listed as one of the faculty mentors. If you've got questions about it, you can reach out. I just wanted to put this on your radar as this is something that you could do in the summer. So yeah, if you Google St. Mary's Summer Research Program, you'll find yourself at this sort of page. And once you're here, you can go to the faculty projects. And this tells you here who's the faculty, what sort of things are they looking for. Some of them have here, I'll go to mine. Some of them have like prerequisites. So like classes that they want you to have taken in order to do research well. So just keep that in mind. I thank you for your feedback in the feedback form. Yeah, we'll keep going. That's helpful for me just to check in and make sure that everything that I think is going on is actually going on. We've got homework 1 that's on Canvas. I've assigned that a due date of next Thursday. Homework 1 in Canvas is right here. And your goal is to create a Java project. And then in that Java project, you create a class for each problem. So if you need help, we should have gone over how to do this, but if you still need help with this, come talk with me and I'll show you.
Did you receive mine?
I did, thank you. I have not graded it yet because I'm waiting for all of the things to come in and then I'll grade all of them at once. That's just easier for me. So yeah, so there's several different problems that we've got on here. So each problem gets its own class file and you just, I've given you some direction. Otherwise, I've given you some output that should match when I run it. So yeah, these are mostly simple projects that you can do with, we'll cover loops and then we'll cover logic. Once you've got those two pieces, you're good to go. Yeah, I do have office hours tomorrow. I want to say 1 to 3. Let's double check. No, 10 to 12. Good thing I checked. I have office hours tomorrow, 10 to 12, if you want to stop by and talk about the homework or how to grab the files or anything like that. I will note for the homework. Do I say at the end? I do. So once you're done with the whole project, and you'll do this for the lab as well. Maybe I should open Eclipse first. I want you to find your project folder, zip that, and then turn in that zip folder. And so the assignment won't allow anything other than a zip folder. So let me show you how to do that. So let's say I'm in my test project. You can choose any project, but ideally this would be your homework project that you've created. So it's the same process as finding a file and turning that in. Same idea, where we right click on it and we go in to show in and then System Explorer, right? So we go and find it in in my case, Finder. If you on Windows, then it's probably System Explorer or File Explorer. Once this is selected, the process varies a little bit from Windows to Mac, but it's the same idea where I want to right click on this folder. That's my project folder. And then on Mac, it says compress this folder. If I click on that, then I've got my project name .zip. That's what I want. If you're on Windows, chances are it says, if you right click on it, it doesn't say compress or zip. Chances are it says send to. So you would say send to, and then there's an option for compressed zip file. So the idea is we want a zip file, and this one you can drag and drop into Canvas. So that's how you do that. Again, if you want me to go over it with you, reach out. Yes. So I've got my project in Eclipse. Maybe there's things in this project. I just click on the project name, or I right click on the project name, and then I go show in, and then I go System Explorer. When you click on that, it shows up in your File Explorer as the project is highlighted, that folder. Right click that folder, and then it should be, are you on Windows?
Yes.
On Windows, there should be an option that says send to. Then if you hover over that, there's another option that says compressed zip folder or file. And then you click on that, and then it gives you a zip file. Okay. Come see me afterwards or during a break if you want to go over that again. Okay, so our plan for today, my plan for today is I'm gonna touch on something for printing that I forgot to mention last time. We're gonna look over loops again and finish what we didn't finish last time. We'll look at logic. And then whatever time is remaining, we'll look at lab 1. This bullet point may change depending on when we start lab 1. So we might have enough time. My goal is I'm going to assign partners for lab 1 based on who's here, and then you can work on it with partner. That way, yeah, so you'll only have to turn in one set of code. We'll talk about it once we get there. But first my plan is a little bit of lecture and then maybe a 3-minute break, and then we'll do lab for the rest of class. Any questions before we get started?
Can we create a check for this?
For what we're about to do? No. So for the lab, no. We'll talk about it. Okay, so I'm going to go back to my Hello World Java. I know some of you in active learning turned in like a new class for a new day. That's perfectly fine. Up to you. I might actually make a new class for today. And today is what? February 11th, and I'll give myself a main. Okay, the thing that I wanted to tell you about is we talked about printf. Remember when we say system.out.printf x, let's see, y, and then z. You may be wondering the %d, that's like a placeholder for a specific kind of data that goes into this string. %d stands for an integer. If I wanted to find out what kind of percent something I use, then I would Google Java printf. And then W3 Schools is pretty reputable. And then you see that they use hello %s. And so you can see that there's different letters here. So if we scroll down to kind of see, oh, look, here's a table of different kinds of data that we can use, or different characters we can use after the % to give us a certain kind of data. So typically it'll be, we've got our primitive values here, right? Where we've got Booleans, characters, strings, decimals, other kind of integers, something for scientific notation, time or date. So there's options, right? That's the sort of process that you would go through to find out. So it just involves Googling Java printf, and it brings you to a page that tells you, here's more about printf and how it works. That's a technique you can use for a lot of the things in this class. Do you have a question? Yeah.
No, no, no.
Oh, okay. Great. Okay, so this is a way of printing out the numbers x1, y2, z3, right? If I run this, it prints x1, y2, z3. Another way of printing things that you'll probably see me do pretty often is to just use sysout. So remember, the easy way to get this is type sysout, and then regardless of whether you're on Mac or PC, do control, not command, control, and then space, and then it autofills that. You'll see me doing something like x plus here, I'll type this out. It's hard to type and talk at the same time. Y to Z3. So it's a lot of quotation marks and pluses. It's unwieldy, which is why I'm not the biggest fan of it personally, but it does the same thing. So if I run this, oh, I didn't add the new line. Let's add the new line. So here the plus operator is doing something that we call concatenation. We'll talk about it when we look at strings as well. Concatenation is basically shoving two strings together right after the other. And so it takes our string X space and it adds 1 after it. And then right after that, it adds Y space. Then right after that, it adds 2. Then again for Z space and 3. So I think the printf is maybe easier to do as for like readability, but in a pinch, you can also use the plus operator for sysout. Okay, that's one thing that I wanted to mention. So that's that bit. So let's look back at loops. Okay. So last time we started looking at the two main types of loops, for loops and while loops. What we talked about is there are 3 basic steps that go into a loop. There's the initialization of where do we start. There's the condition of how do we know that we're done. And there's the update of we have a starting point and an ending point. How do we actually get there? What are the steps that we take? We talked about condition, where something like x less than 3, that's read as a question. of is x less than 3? Is x equal to 10? Is x greater than or equal to 4? So the condition is a question of, are we done yet? It's like the kid in the backseat on a road trip of, are we there yet? Are we there yet? Are we there yet? At every single mile, we're asking, are we there yet? We talked about the update step where we had an experiment where we looked at adding 1 to I and seeing, are these the same? They do basically the same thing. And I think we stopped at looking at changing the step value. Let me open that and see where we got. Right, so I think we tried this version, which breaks. But yeah, so the idea runs true, right? We have to start somewhere. We don't have to start at 0 every time. We can start at 10 and then we can go down to 0. We can start where we want to start and stop where we want to stop, just as long as we have a way to get there. Okay, so you may have noticed the way that we write for loops in Java is we have the word for, it has to be lowercase, all one word. We have to have parentheses. And then first we need the initialization step. So in this case, we've got int j equals 10. That's the initialization step. We could have, so maybe if I defined I somewhere else, maybe if I start I at 2, you'll typically notice like for int I equals 0, that's where we start. And then if I say, let's go I less than 5, I plus plus, and I'll just print you are cool times I. What's the problem here? The error says duplicate local variable I. What does that mean? What do you think? Yeah,
You initialized I outside of the float and you're calling it again.
exactly. Yeah. So remember, initialization is when we say, here's what type this variable is. So we've said, I want a variable called I. It's going to be of type int. And here I'm initializing it again, where I say I want a variable of type I, and it's going to be an int. So we don't have to initialize, or maybe if I just initialize and not, or maybe, no, sorry, words. If I declare I and not initialize it up here, so that way I know I'm going to use I. And then I can just say in the initialization step is we start I counting at 0. So we don't always, you don't need int I equals 0 in there. You could declare it up above and just say, here's where I want to start with this variable I. So now if we run this, it prints you are cool times 0, you are cool times 1, 2, 3, 4. 4 times cool, hooray. Right, so first we've got the initialization, then we've got the condition, then we've got the update step. And so this is a packet problem. If you want to take a few moments and go through and write for at least some of them, what's the initialization step in the loops that are here? What's the condition? What's the update?
Um, Oh.
Sarah?
Yes.
No way.
You've done the worksheet bit,
What would she do?
the initialization. This page. I think we have time to do this. Great, okay.
Mine's already running.
You're ahead of the game. Okay, so that's for loop. While loops are really similar, they just, some of the pieces are just moved around, right? So this is kind of a summary of what that looks like, where with a while loop, just like Python, there's a condition there. The condition has to go in parentheses, and the initialization goes before that. And then we have to remember the update step within the while loop. So that's the other bit, which is basically the same ones as problem 11, just moved around. So yeah, so I think we'll keep moving on. Okay. Now we'll look at logic. If you remember from Python, we did logic something like this, where we have some, in this case, I'm reporting on the size of some variable x. And so when I start, I have x equals to 5. Then I say if x is less than 4, then I'll print small. If x is between 4 and 6, I'll print mid or medium. And then otherwise I'll print big because x is bigger than all of that. That's how the logic works, right? We have the word if, and then some condition, and then a colon. The sort of branching case of else if is spelled ELIF. Then we've got a condition here and a colon. So we're able to do the same things, it's just spelled differently. So in Java, if is also spelled if. Else is also spelled else, E-L-S-E, all lowercase. Else if is not elif anymore. It's actually the words else space if. Do I have, no. So yeah, after when we need a condition, we need to put it in parentheses. So let's see what that looks like. So after this, I is going to be equal to 5. So let's just do this same logic, just in Java. So we'll say if, and then we need parentheses. So if x is less than 4, and then instead of a colon, remember in Java, we're using curly brackets. So we'll print, what did we print? Small. What I am typing. Hope.
Wait. Which project?
I'm working on the in-class project. So whatever you've named that project to be. Okay. Nah, I'll just say int x equals 5 and save myself the headache. Okay, so we've got x equals 5. Then we've got if x is less than 4, then we print small. Otherwise, if x is greater than equal to 4 or less than 6. So the way we spell this in Java is else if. Then we have a condition, so we need parentheses. X is greater than or equal to 4. I'll type that first. And X is less than 6. Curly brackets. We print mid. But now we've got a problem because in Python, we could use like literally the word and to express that Boolean operator. But Java doesn't let us do that. That's okay because it's just spelled differently. So, and in Java is spelled with 2 ampersands right next to each other. Or in Java is spelled, do I have a picture? Yes, I do. So typically on a keyboard, there's the backslash character. And then if you press shift and press that key, it'll give you like a long, skinny straight line, which is the pipe. Sometimes it may also show up like over here on your keyboard, but typically I think it lives over here. That's what we call the pipe character. So it's not the letter L, it's something different. And then if we want to say not, then we use the exclamation point. That's how we say not something. Okay, so instead of the word and, instead I just need 2 ampersands, and that gives it to me. And then otherwise, we don't need any parentheses here because there's no condition for else. Else just takes care of all other cases. What did I say? Big, probably. Okay, so if X is 2, then it should print small. If X is 5, it should print mid. If X is 10, it should print big. Sure. Okay, so we're working with the logic here of if X is less than 4. And so on. I'll post the code after class as well, so that you can copy anything over that you need to. Okay, just to practice. Nope, I want to select this. If I type shift and then that backslash key twice, it gives me these 2 long parallel line characters. So make sure that you can find the pipe key on your keyboard. Let's say we could say if X is not equal 4, that's how we type that. With the exclamation point and then the equal sign, that's how we say not. And then similarly, if we say if X is equal to 5, the way we ask that question is with 2 equal signs. Right, so those are our logical operators. All right, let's see. Yeah, so this is what we just typed, where it's just spelling it a little bit different, formatting it a little bit different, but it's doing the exact same thing that we knew how to do in Python. So if you are working on something and you're like, I know how to do it in Python, try and take it bit by bit and ask. So for example, how do I write an if statement in Java? And if you Google, how do I write an if statement in Java, they'll give you something like this, where you need if, you need parentheses, you need curly brackets, and then you can fit the puzzle pieces in for things that you knew how to do in Python that now you can do in Java. A question I have for you, where are the semicolons? So this is one of the packet problems too, or yeah.
Yeah, it's like at the end of like the system, well, one of the places is it's like, if you're like, for example, if you're like declaring the variable int x equals 5, that's like one place, and then another place is like at the end of like the system dot out dot println. Yeah.
Yeah. So the thing I want you to notice is that the semicolons, for example, aren't here. Like we don't have x not equals 4 curly bracket semicolon. Or the semicolons aren't after the parentheses. That's not where they go. The semicolons go after each code statement. The logic is helped to set up to tell us which statement to execute. So yeah, so it's not in the if, else if, or else. It's only after the actual statements, the code statements that we write. And similarly, let's go back to the for loop. For like the while loop, also the semicolons only go after the actual code statements, not after the parentheses or after the curly brackets. They're only going after each code statement that we write. Okay. And that's a packet problem. That should take you 10 seconds to just circle. Here's where the semicolons are. And hopefully that helps you remember. Okay. So, we're going till 5. So maybe let's take like a 2-minute stretch break and then we'll come back, get your computer set up, and we'll work on lab 1. Yeah, do you have a question? Yeah. Like 4 or 3. The class not saved. You can see that little asterisk there. Okay, now it's saved somewhere. Okay, open the door somewhere on the binder. Yeah, or you can go. So in. Where did you drag it up? Okay, are you dragging it up? You dragging it up like into the center of it? Yeah. I'm dragging it up into here, like in the basics. In source.
When we put it in the past, and put the CSV too.
Sure. Occupies, yeah. Okay, so now you should be able to drag it up into the basics folder.
Oh, it's here, that's more than I need.
Right, yeah, but you need the project structure. Define this word.
The drag and drop it.
Drag it up and well into school. So the one we've got in
One, I'm sure you can do that.
this is one of the things where like Eclipse is weird. I would make a new class in basics, just copy it.
How do I do that?
So, that will new thing here, with class. We'll name it Hello World. And then that's fine finish. And go to your old level. Yeah, copy, yeah, copy it in. And then paste it in here. Yeah, and now you're, yeah, the brackets, double check the brackets.
Okay, got it. Thank you so much.
Any other questions I can help with on over here?
I'm trying to run my homework so far, but I'm unable to.
Editor does not contain a main type. Okay, so we've got public fast tracked. Okay, so first thing I noticed is we want all of our code to be inside the source file.
Okay,
The LRC stands for source.
okay.
So if you're able to maybe drag and drop it into there, is that possible? Oh, no, default package. There it is.
Okay.
Default package just means that it's expecting that there's like a organizational folder in it. You just haven't made one.
Okay.
So now if we double click on trapped, just to make sure that we've got it open in the editor. Okay, so what's the very first error? If you hover over that. Right, you just have to like hover over it. Must declare a named package because. Okay, so try right clicking on default package. And the rename option. So maybe refactor. Yeah, okay. So this is one of the reasons why, like, if I'm making a new class, then I want to make sure to like type a package name. So one of the options is to just make a new, like, I don't know, like it's
Yeah.
just like, if for homework one, you could call it like my problems or something. The package name doesn't really matter. And then call it trapped and then just copy and paste your code.
Okay.
And then, so the thing that it's looking for is this line of
Are you
code.
still on break?
Oh, I guess not. But yeah, the thing that it looks for is this line of code that says package basics semicolon.
Okay.
That says, here's the folder where I'm going to find this code. And so when you open it in Eclipse, you've got your project name, you've got your source folder, and then you've got basics folder.
Wait, is this line one?
Not yet. We're about to do lab one. Okay. Any other questions before we get started? All right. So we're going to work with labs now. And so labs are just another name for a kind of assignments that we're doing. The labs are, I will tend to have you maybe start them in class and finish outside of class, or depending on how it goes, we'll do the whole thing in class and then you just turn it in. So yeah, so it might be homework depending on how it goes. The idea for labs are to be slightly easier than the in-class examples that we look at. Sorry, slightly harder than the in-class examples we look at, slightly easier than the homework problems. Because the labs will kind of try and guide you step by step. Whereas homework problems where I say, here's what I want, and you have to figure out how to get there. So what we're going to use for the labs is something called Git. So later on in the semester, especially once we get closer to the project, I'll show you and once we work with bigger assignments, I'll show you how to use it. But to avoid cluttering everything up, I'm just going to show you what you need to know to work on the lab. So Git is something that helps with version control, which is it's a way to share files with, so like if I'm on my computer and you're on your computer, we can share files with Git. It's also used for version control, which is if you make a change over here and then you're like, wait, I deleted that, I want it back. Or I made this change, but I don't like it, I want to do something else. Then version control lets me recover that old version of the file. I did this recently. I was working on a code project with someone, and turns out the new version that I wrote wasn't doing what I wanted it to do. So because I have version control, I can just pull the old file and make that the version that we work with. And it lets us collaborate with others. So in this case, I've written the lab and you're all going to download it. So the lab code and sometimes other code for this class is going to live in the cloud. And so there's a link here, but let's verify it. If we go to the Canvas page and we go to lab 1, hopefully I put the link there. I did. So if we go to this link, it takes you to this page. So let's talk about this. So this here is the name of what we call the repository. The repository is basically, here's this group of files. And then over here, we've got the list of files of the code that lives here. And then we've got a README, which these are the instructions for the lab. So you'll read through, like, here's the introduction, here's me telling you what is going on here. Can you go to lab 1 on Canvas?
I did go what?
Did you click the link?
Yes.
Great. Then you're on this page with us.
Oh,
Yeah, you might be in light mode. I'm in dark mode. But yeah, so we've got our introduction. We've got the instructions. The instructions are, I try to make them bare bone in this area, and then you can click like, how do you install JDK? How do you install Eclipse? And so then we've got writing to say, here's what you do, and then you can click go back to the instructions, and you go back here. So that's kind of how it's set up. So yeah, so there's sorry, I scrolled too far. There's 4 main parts to this lab. First off is installing stuff, which you've already done, and cloning, which we'll talk about how to do. And then in general, for the beginning labs, I'll try and have 3 main activities. So beginning, middle, and end. And so beginning has 3 steps, middle has 1, 2, 3, 4, 5, 6, 7 steps, and then end has 2 steps. And then finishing up is just turn it in. And then explanations, this is where I have writing to, if you need help to figure out how to do that, then there's instructions there. There's stuff on the right-hand side, there's stuff up here. You don't need to worry about that. This just says what language it's worked in. Yeah, you can ignore that stuff. So we've got this code in the cloud. Let me actually show you the code. So what I've got here, this is an Eclipse project. So if we go to the source folder, then we can see this class beginning. We want to be able to download this to our computer. And there's an easy way to do that. First, what we have to do in Eclipse is we need to switch to the Git perspective. So that's this little itty bitty tiny thing that says Git. There's a golden cylinder and then words that say Git on the top right. So when I click that, the layout changes a little bit, right? I've still got my editor open. There's a little, on the top right of your Eclipse window, there's a little, it's not, okay, wait, let me see. Oh, yeah, let me show that. Let me show that. I love doing this and it doesn't show up. You're using Visual Studio? Yes, we'll get to that. So yeah, so how did I get there? If I'm in the Java perspective, chances are there's a little white window with a little plus thing right next to it. That's this guy. So if we do this and then we select Git.
I don't have. I don't get.
Okay. I will come walk around for a second. This is another one of the things where like we have to take it step by step. Then once you do it once, then you can do it a million more times. Okay, click on that. Select Git. Open. Great, you're there. Okay, anybody else having trouble? Okay. In Visual Studio, let's open, let's see, where did I have my sample Java project? Okay, so let's say I'm working in my sample Java project. So Visual Studio has this sidebar thing where here's, cool, then you can ignore this. But just in case, if you ever needed to use Visual Studio Code for Java, there's a little sidebar here. The two files on top of each other, that's your Explorer. So here's all the files that are there. You can search for things. And this is what we care about. This is the source control. Actually, no, sorry, I'm getting confused. To clone something in VS Code, I'm going to open a new window. So I do that Command-Shift-N, or on Windows, Control-Shift-N. And that's going to give you a page that looks kind of like this. And then you just say clone git repository. Or if you open this page, then there's an option to clone the repository. Does it, do you, you may not,
That one, source control, it says, download Git for Windows.
yeah, download Git for Windows. Once you download Git for Windows, then you have this. And so then you can click clone repository, and then that's kind of where we're at. Okay, so I'm going to keep going with Eclipse, and then once you catch up, we'll talk about VS Code. Okay, so in terms of changes for what's different now that we're in Git perspective, the package explorer, you'll notice, is now named Git repositories. This is one of the clues that you're still in the Git perspective. There's also other things down here that you can pretty much ignore. Now's this part where I tell you don't speed through these steps. Because when you're using Eclipse, there's a specific little box that you have to check. And if you don't check it, it makes your life hard. So be careful. Okay, so the way we're going to do this is we're going to clone the repository that lives in the cloud. So there's a little icon. I'll show you in a moment. So there's a little icon that's this little golden cloud with the little golden cylinder, and there's the arrow that's going to the golden cylinder, right? So I can find that right here. It says clone a Git repository and add the clone to this view. If I click on it, something pops up. Did it not pop up for anybody?
Says select repository source.
Great, you're there. Okay. So we are going to select clone URI. Stands for Uniform Resource Identifier, as opposed to URL, which stands for locator. So we're selecting clone URI and then click next. And that brings us to a different page. Now we need the link to the code in the cloud. So if you go back to the GitHub page, oh, by the way that I'm doing this, like switching between windows, on Mac, it's Command Tab. On Windows, it should be Alt Tab. That just lets you like swap. I think Windows works a little bit differently, but it lets you like swap between windows. It's extremely handy. I love it. So if I go back to the lab, to just the main page, I'm looking for this green button that says code. If I click on it, something pops up. And you may notice there's a link here, the HTTPS link. That's fine. So there's a little 2 squares that you can copy to clipboard. And then once you do that, now we're going to paste it. So URI is here, just in that first field. You can ignore pretty much everything else. So then I click next. Branch selection, ignore, click next. There's only one branch. And then once you get to, this is the step that you need to not speed through. So you could just be like, oh, finish. But no, there's something you need to do first. Did we all get to this screen? Okay. Okay, so the first question, how do you find the link? On the GitHub page, you can either, technically, I think you can just like use this link, but I recommend,
Oh, I got it.
yeah,
Okay.
if for the green button, you click the button that says copy URL to clipboard or URI to clipboard. I don't know which one that is. Okay, one of the things I'm going to ask you to do is to name the directory where it goes. So it auto-filled users SRR6 get CS222 lab 01. That's what it auto-filled because that's the name of the repository. Something that is very helpful for me for grading is to know whose lab assignment it is, which I'm just now realizing may change when we have partners. But just for now, I'll just ask you to like put your own information there. If you're working with partners, I would ask you to put like your and your partner's name there. So because this tells me when I open it, oh, this is this so-and-so's code. That way I don't have to like go and rename it and risk getting mixed up. So this is just a note for me personally. If you forget that, it's not a big deal. So I'm going to add right here my first name, last initial. It's not going to let me do a dash, so I'm just going to leave it as is.
Why?
So I'm saying before CS222, write your first name and any last initials. So for me, it's Sarah R. Question.
I'm not getting the local destination. Oh. Oh, my bad.
Yeah, there you go.
Sorry.
Okay, so I've named it something, and now here's the very important box that you must check. Otherwise, it makes your life miserable. There's a little box that's by default unchecked for some insane reason that says import all existing Eclipse projects after clone finishes. Well, it is checked for me, so that's great. But you need to make sure that it's checked, because if it's not, then it doesn't show up. So once you make sure that you've named it correctly and this box is checked, you can click finish. And so you guys go ahead and click finish. I'm going to uncheck it to show you what happens. Okay, so hopefully it should have shown up here. And then if you go to, if you go back to the Java perspective, it should show up in Package Explorer. For me, it didn't because I had unchecked that box. So if I'm going to, now I have to import it manually. I'm just going to show you in case you need to know how to do that. So I go File, Import, and then I think it's Projects from Folder or Archive. Then I have to go and find it. So for me, it lives, let's go Applications up, lives in Users, My Accounts. It lives in Git. And I've got 2 versions of these, that one. And once I do that, then here it shows up back in Package Explorer. Make sure once you're done with this step that you have gone back to the Java perspective. I see a lot of times, I see you're like working on things and you're trying to run it and you're like, where is it? I can't do the things that I want to do. That's because you're in the wrong perspective. So yeah, so make sure to go back to the Java perspective. Sure, just a moment. So the rest of the instructions for the lab, because it's just an assignment, they're in like the GitHub page. So what you could do, you could like open the README over here and scroll through it in Eclipse. I don't know if the links, I guess the links do work. Go back to the instructions. I don't think the backlinks work. So unless you want to scroll a lot, my suggestion is to maybe read through it on the web and then toggle between your browser and Eclipse. If you're doing this in Visual Studio Code and you select Clone Repository, it's basically the same process where you just ask it, like, where's it going to go? I'll put it there. And then it clones it by itself. And then you can just open it. So Visual Studio, it's easier. There's less steps. But I like the standards that Eclipse enforces. Okay, so we've got half an hour. And I think what I'm going to do, I will stop recording. I'll put you guys into groups. And then you can work for the rest of the class on the lab. And then once you, we've covered most of it. So I think I won't leave it for next class. I'll have you, if you don't finish today, then you just work on it outside of class. So connect with your partner, share contact information if you didn't finish it today. Sounds good? Okay.